Hello all, I am Sindhu C. In this video lecture, I'll be discussing about the concept of union in C programming language. The contents in this lecture will be starting with introduction of comparing a simple variable, an array variable, a structure variable and a union variable. Moving on, we'll see how to declare a union and what is the storage status of union members, how to access a union member, what are the various limitations of using union. Then we'll compare union and structure with its differences and similarities. Then we'll find out when to choose union, and finally with a small snippet uh, what is how to use union within structure and structure within union. So with that, we'll start. Introduction. In this introduction section, I'll be discussing the relationship between a primitive variable, an array variable, a structure variable, and a union variable. So here, let's start with a variable, which is a primitive variable. A variable is a data name that can be used to store a data value of any data type. So it basically stores a primitive data type value. Here in this example, we have int value is equal to 10, where value is a variable name. It stores a primitive data type value which is 10 of the type int. Secondly, we will be analyzing what is an array variable. An array variable is a fixed size sequenced collection of elements of the same data type in contiguous memory location. It is of the type derived, where you can have multiple values of the same type. So let's have an example. Int values, inside the square brackets we have 5, which means we can store 5 values of the type int. So here the values are 1, 2, 3, 4 and 5. So a primitive data type variable can store only one value. It can be of any primitive data type value. A array variable can store multiple values of the same type, and it is always stored in contiguous memory location. A structure is a constructed data type for packing data of different data types together. So here under a single variable name, you can have multiple data type values. Here take an example, struct student, inside parenthesis you have 3 members, which is name, which is of the character array type, age, which is of the integer type, register number, which is of long int type. Here student is the tag name, struct is a keyword. You have Sita, Ram, Krishna and Radha. They are called the structure variables. So these variables hold the memory spaces where you can store in some data for name, for age and register number. So here this structure is a constructed data type where you are constructing some memory locations with respect to the various members of the structure. Here the members are name, age and registration number. So now you can see the relationship between a primitive variable, an array variable and a structure variable. An array variable stores multiple values of the same data type. A structure variable, here in example say Sita, it can hold multiple values of different data types, say name, age and registration number. Now union is just similar to this. You can simply use union student and the rest of it the same. So there is no big difference between how you define it. Introduction to union. Unions are concepts borrowed from structures. They are very similar, unions and structures. Union is another compound data type which may hold the members of different types and sizes, and the compiler keeps track of the size. Hence, we follow the same syntax as structures. The major difference between the structures and unions lies in storage. In structures, each member has its own storage location, but in union, all the members use the same location. Although a union may contain many members of different types, it can handle only one member at a time. That is the significant difference between a structure and union. Union declaration. So we start the union's declaration with the keyword union. Here we have an example, union cube. Here cube is the tag name. We have three members. So the members are side of the type int, volume of the type float, and code of the type character. Now red is the variable, union variable. So this declares a variable red of the type union item. So now you can think of this red with three memories together. So one is side, volume, and the other one is code. Of all these are of different data types. So explaining the same, the union contains three members, each with a different data type. However, we can only use one of them at a time. So why we can only use one of them at a time is due to the fact that only one location is allocated for a union variable, irrespective of whatever size it may be. So with respect to the example that we have seen, say for example, code. So code is the member of the type character. It takes 1 byte. Side is the member which takes 2 bytes because it is of the type integer, and volume is of the type float, so it takes 4 bytes. So the same 4 bytes are used by all the three union members. So at a time, only one member can be using the memory location. So we'll see an example with which you can understand it. The compiler allocates a piece of storage that is large enough to hold the largest variable type in the union. So in the example that we discussed, the member volume takes 4 bytes, which is the largest among the members. The others are int and char. So obviously the volume member, which is of the type float, it takes 4 bytes. So it is the largest among all the members of the union. So your union is allocated with 4 bytes. With that 4 bytes, all these three members have to allocate and deallocate and accordingly use it for the other assigning and initializing purposes. Accessing a union member. So to access a union member, it is just the same as how you access your structure. So what operator we use is the same dot operator, which is called the membership operator or the period operator. So here we have an example. Red is the variable. So red dot side together is the union member. Similarly, red dot volume is the union member. Again, you have red dot code, which is the another union member. So all these are valid union member variables. We have few limitations with respect to union. So the first question is, what should not be done when we access a union member? So we should make sure that we are accessing the member whose value is currently stored in the memory. So in our example, we had three members, one of the type character, one of the type integer, and one of the type float. Now here you can recollect the example. So red dot code is equal to C. So this code is of the type character. We are trying to assign the value C to code. And then the second step is we are trying to assign 5 to the member side. Then in the third step, we are trying to print red dot code, which is assigned in the first step. Now currently in the memory, red dot side is currently allocated with 5. So the union's current memory location is loaded with 5 and it has no access to red dot code whose value is C. So that value is currently not available. So this is the main restriction. So if you try to use these three codes in sequence, you will be getting a erroneous output. So if we actually try to look at it, we have three union members, and in the first step we are assigning a member with a value. In the second step we are assigning some other member with another value, and in the third step we are trying to trace the value of the first step's value. It isn't available because whichever is currently loaded with value, that is to be, or you can say whichever is recently loaded with value, that member can be accessed. The others are overwritten. So that is the basic limitation of using a union. Then why should we go for union? Union occupies less memory space and it is an advantage in other way. So wherever we need to handle something with less space, go for union. Otherwise you can always use structures. The other points that you might have to know about unions is unions may be used in all places where a structure is allowed. The notations for accessing a union member which is nested inside a structure remains the same as for the nested structures. However, how you use a nested structure, the same way you can use union and structure. Then a union creates a storage location that can be used by any one of its member at a time. That is, only one member can access it at a time. When a different member is assigned a new value, the new value supersedes the previous member's value. That is what we saw in the previous slide. Now, unions may be initialized when the variable is declared, but unlike structures, it can be initialized only with a value of the same type as the first union member. Here you have an example. Union shape square is equal to 5. Considering this square is a variable of the union shape and the first member is of the type int. Say if the second member is of the type float or the third member is of the type float, then this statement is not valid, which is union shape square is equal to 7.5, because it is not the first member. If it is the second, third or any other member, then that cannot be done. Only the first item can be initialized. That is what is mentioned. It can be initialized only with a value of the same type as the first union member. So here union shape square is equal to 5 is valid, but union shape square is equal to 7.5 is not valid. Okay, so considering the fact that the type of the first member is int. Other members can be initialized by either assigning values or reading from the keyboard. Those are the other options. Now let's look at the basic differences between structures and union. So we know that struct is the keyword used to declare a structure and union is the keyword used to declare a union. The variables that make up the structure are called the structure variables, and the variables that make up the union are called the union variables. All the structure members can be active at the same time because you can put in some values and you can access it anytime randomly. But only one union member can be active at a time, and that too whichever is assigned recently. All the members of a structure can be initialized, but only the first member of the union can be initialized. When it comes to structures, it allocates the total size of all the elements in it. But when it comes to union, it allocates as much memory as its largest member requires. In the case of structures, more memory space is required since each member is stored in a separate memory location. In the case of union, only less memory space is required since all the members stored in the same memory location. Now, when it comes to structures, all the members are stored in separate memory locations throughout the lifetime and scope of the entire structure. In the case of union, only one actual value for one element at a time will be stored. In the case of a structure, any manipulation occurring with one member will not affect the values of any other unless they are operated on in code to do so. But in the case of union, if any other element stored before the first is retrieved, then the first stored value is lost. That is, the second value supersedes the first one. Now, in short, you can keep it like this. The members of the structures are ANDed together. But in the case of union, members of the union are XORed together. So that is the easy way to keep in mind. These are the basic differences between structures and union. Now coming to the similarities between the structures and union. So first is the use of dot operator to access its members. So it is struct dot member and union dot member. So whatever it is, variable dot the member is used in both structure and union. Then the second is using brace delimited declarations to create the template for the data object is common for both structures and union. Then the third one is using tag name and name as well as explicit initialization as options. So we have already seen in the structures lesson where tag name and name they are optional. The fourth one is use of size of operator to determine their maximum size in bytes. So using size of operator works with both structures and unions to determine their maximum size in bytes. So these are the basic similarities between structures and union. When to choose union? It is up to the programmer to decide. I've shortlisted 3 points. The first one is if member access is dealt with closely and no commotion may prevail, then you can go for union. Union may only be initialized to a value appropriate for the type of its first member. Then using union, it makes sure that the recently accessed member is active, and to use some other union member, we should activate it. So if all these three can be satisfied, then you can go for union. And we should avoid union with widely varying member sizes for the larger data types. So in those cases, you can consider using pointers instead. Now, we can use union within structure and structure within union. So here is a small snippet. Hash define radio 1, hash define TV 2, hash define watch 3. Now you have a structure. It's radio specification with number of bands and number of batteries. TV specification with number of speakers and tube size. Watch type with power. Now you have another structure, item type, inside which you have two items. One is of the type int, the other is of the type union. So this integer item is item flag. Then you have the union, which has three structures in it. And the union's variable is of the type item. So there are possibilities where you can use union within structures and structures within union. So you can see that inside item type structure, you have a union, and inside diff type union, you have three structures. So this nesting is possible. So far in this video lecture, we have seen the relationship between a simple variable, an array variable, a structure variable, and a union variable. Then how to declare a union, the storage status of union members, how to access a union member, the various limitations of using union, then the comparison between union and structure, its differences and similarities, then when to use union, when not to use union, and how to use union within structure and structure within union. So that option is possible. We saw a snippet through which we did understand how to implement union within structure and structure within union. So my basic reference was Programming in ANSI C, third edition by Professor E. Balagurusamy. Thank you and good luck.